Hi guys, today we're going to be looking at a combinatorics problem that has a twist off of the classic combinatorics problem. The letters M, E, T, E, O, and R can be used to form 6-letter strings such as meteor or EEMTOR. Using these letters, how many different 6-letter strings can be formed in which 2 occurrences of the letter E are separated by at least one other letter? The challenge here is that we're given some special circumstances for what would be a success or a failure. That is, we're not allowed to have 2 E's in a row. And we can tackle this problem from 2 different directions, ultimately with the same solution path. If we take a look at it and say we know how many different 6-letter strings we can find as a permutation, and then adjust for the 2 E's being identical into combinations using our combination formula, we can then reduce down from that the number of ways that the E's are together. Alternatively, we can figure out all the successful pairings of the E's, that is when they're not adjacent, when they're not next to each other, and then figure out how everything fits in between. I'm going to take you through both journeys. From our classic permutation formula, we know that the number of ways we can order 6 letters is 6 factorial. 6 ways to put 6 different letters to put into the first spot, 5 remaining letters to put into the second spot, and so long. 6 times 5 times 4 times 3 times 2 times 1 gives us 720. You don't need to know that, but it's the first factorials up to really 6 aren't bad to sort of have bouncing around in the back of your head. Starting from that 720 ways of combining, we know that we've got identical cases. So the meteor that we spell M-E-1 T-E-2-O-R is the same as M-E-2 T-E-1-O-R. So we need to adjust our 720 down by the 2 different ways there are to order the E1 and E2, technically 2 factorial. So that takes our 720 and brings us down to 360. Then we need to figure out how many different ways there are to have those E's adjacent to each other. So they can be in spots 1 and 2, 2 and 3, 3 and 4, and so on. So there's 5 different ways. For each of those 5 ways, there are going to be 4 factorial ways to order the other letters. So we have 5 different ways times 24 different orders, 120. We take that 360, subtract the 120, and get to 240. From the other side, we can say, well, how many different ways can we order the E's where it's a success? And this is a small enough problem that we can enumerate them. We could also use another permutation formula of 6 choose 2. But we have E blank E blank blank blank. So in spots 1 and 3, 1 and 4, 1 and 5, 1 and 6. 2 and 4, 2 and 5, 2 and 6. 3 and 5, 3 and 6, and 4 and 6. That is 10 different ways. Applying the same reasoning that we used before, there are 4 factorial ways to order the other letters. So 24 times 10 equals 240. Now we can get creative and bring in things like Pascal's triangle to make some of the computation a little easier. But really, if you have that framework to either build up or break down, you're going to have an easy time handling these pivots that the 700 plus GMAT combinatorics problems are going to throw at you. Subscribe below, leave your questions and comments, and thanks for watching. Have a great day.